It's the same order that I shared in the playbook.
Hmm.
Please try and keep it to about 7 minutes so that we have plenty of time for discussion. Um, and yeah, I think we can probably kick off now. Good. So, good morning, everyone. Good morning, and whether you're joining from Zoom, LinkedIn, or YouTube, welcome to the third day of the 2026 edition of the AFSIA e-conference. For those of you who are joining for the third day in a row, give yourself a pat on the back and know that we have another great day of content for you lined up, so don't go anywhere. And for those of you joining for the first time this year, also give yourselves a pat on the back because what a time to join. We're going to have some amazing discussions today. But before I tell you what's coming up, I just want to say a big thank you to our event partners for supporting us and helping make this event a success. So, to give you a little flavor of what's coming up, the storage sector, if you've read any news article anywhere or joined us for the last 2 days, you'll know the storage sector is evolving, and therefore so must the e-conference. So today, what we've got for you is two very important conversations taking place. One between industry and C&I off-takers, and one between grid operators, OEMs, and project developers. So stay tuned for what promise to be some excellent and thought-provoking discussions. Before we get on to our first panel, just a few elements of housekeeping. Um, don't panic because the recording will be shared after the event. Please put your questions in the Q&A along with who you would like to answer them. If it is a general question, please put that it's a general question. Otherwise, I will just embarrass myself by asking it to the wrong person. Um, and I can see several of you are doing it already, but use the chat for networking with other participants. So, on to our first conversation. So, CNI solar and storage is, in many cases, the driving force behind some of the most vibrant solar markets across the continent. And as we've seen, CNI customers are increasingly turning to solar and BESS for a resilient and robust power supply. However, as AFSIA, one of the biggest requests we get from corporate suppliers of renewable energy is for introductions to corporate buyers. On their side, corporate buyers feel deeply the need for more reliable power, but questions remain for them around the technology and its suitability for their industries. This mismatch is exactly why we've convened this panel, so that project developers, OEMs, and C&I off-takers can exchange and begin a conversation that develops greater understanding between corporate buyers and suppliers of renewable energy. So without further ado, I'd like to welcome the panelists for this excellent discussion. Representing the off-takers, we have Ludovic Bernard, CEO and co-founder of Horus Labs, a modular data center company. Abdunnour Yahi, representing the OEMs, the technical and marketing manager for Africa from JA Solar. And representing the project developers, we have Swaleh Hassan, business development manager for Gadgetronics Tanzania and business director for Gadgetronics Kenya. And representing the EPCs, we have Adewale Odugbesan, CEO of Royal Power and Energy. Now, before we get into the discussions, we're going to have a short series of presentations to set the scene from our excellent panelists. So first, I would like to ask Ludovic to turn on your mic and camera and start sharing your screen. I pass the floor to you.
Hello, Benjamin. Thank you so much. Just can you please confirm that you can hear me well?
Can hear you crystal clear.
Very well. So I've gone ahead and shared the screen. As it starts to do that, let me go ahead and introduce myself. I am Ludovic Bernard. I am COO and co-founder at Horus Labs. Horus Labs is an digital infrastructure company. We provide cloud compute in essence, but we have done a foray into the data center space to be able to serve cloud compute in a sovereign angle for markets that still need it, notably in Africa. And so Rwanda is our pilot project. And so in order to do so, we also need to be able to take one key look at ensuring that our energy is being matched in the correct way, right? So we'll go a little bit into this about why the solar component is so important for us, but in a nutshell, we can depend on the grid to some extent in Rwanda, but at the same time, the cost factor and other implications, especially with quality of power, mean that the solar component is very useful for the data center space. If you can all confirm that you can see my screen, we'll go ahead with a presentation. Okay.
Yes, we can see it.
Perfect. So yeah, so our goal is really to be able to bring sovereign compute on African soil, right? The access to cloud compute for consumers on the continent typically has been one of where they have to go offshore. And with more and more data sovereignty rules, we need to find ourselves in a way to be able to have solutions on the ground. And so we bring modular AI-ready data centers, modular being small footprints, oftentimes not more than 100 square meters, where we can easily bring in 1 megawatt of IT load on ground. This is really brings us to be able to serve at least most of the demand in most countries at this current moment, and we can grow in a modular way as the demand starts growing as well. Okay, so all right, yep. So like I said, we're a private infrastructure company, and we're building this digital capacity via data centers and most notably cloud compute, right? There's an AI component to this as well, where we have an AI component to our data centers for AI loads that need to take place. And then we are crucially focused on being able to offer disaster recovery workloads as well. So our first deployment is going to be in Bugesera, Rwanda. It's for those of you who are familiar with Rwanda, and those of you who are not, it's 45 minutes south of Kigali, the capital. It's also the location of the countries or the cities next to international airport. And we are planning to put a 1 megawatt IT load data center there, which is expected to launch mid next year. So, and with this, the solar component is a key factor. For us, why do we think that why data centers are so important is just because, one, as was mentioned before, the sovereignty gap is filled. There's a lot of loads that have to happen locally and will continually be the case. In Rwanda, it's the law. In other places, in other markets, we foresee it will become the law. And then again, we want to be closer, right? You need to have the reliability gap is crucial as well. The further away you are and your compute is from the market, then the slower it is. And we call it latency, but we need to ensure that this is close enough to our consumer base as possible. And then the compute gap, right? Modern compute platforms require dense power, advanced cooling. It requires proper data centers that can take on the loads that our clientele demands. And right now, unfortunately, this is not as prevalent as we would wish it to be. And as Horus Labs, we hope to fill that gap. So what power challenges do data centers face? With higher rack densities to cover these loads, we have increased cooling and electrical distribution demands. And this power volatility that comes with our current grids raise operational equipment risk. We can't only use diesel as backup because it's costly and then it's not sustainable from an environmental and from a general maintenance and cost perspective. And then in markets, especially like ours, we have high power charges, right? In Rwanda, even our data centers, we pay around 15 US cents per kilowatt hour. It's 5 times more expensive than the cheapest you can find, and probably double the cost of most markets. And so these high power charges and the constraints that come with the grid are also, they weaken the project economics and our ability to be able to launch it forward. So given this, we really want to be able to go ahead and make sure that we have a solution, and the solar component really helps here. So as you can see, typically in our setup, what would happen is we have the grid, which is the primary supply, the renewables, like in the case of solar. And so as much as we can legally put up, we wish to be able to put up to full megawatt. We'll see what the law allows us to do in terms of captive power regulations. Then, of course, we have generators like diesel for resilient backup. And then to many people's questions, yes, we do want to put a BESS system. BESS, in our case, we want to put a 2 megawatt hour BESS system. That for us is generally okay, but the value it brings is much more than just a storage, right? It also helps us not have to turn on the generators at all, even when there's a small brownout. And there's less wear and tear on our UPSs because of, say, the fluctuations in the grid. And so all these things translate to cost savings for us in terms of being able to have a better SLA for our clientele. And from the BESS, it goes to the secure power system. These are the UPSs I was just mentioning, and the switchgear and bus bars that eventually lead to the data hall where the service will lie. And so to the point I was making before, BESS is very key for us because of energy resilience, the integration with the solar platform itself, the solar array, and then optimizes our use of the UPSs, the generators, which has in turn reduced our use of diesel, and in the end provide the strategic outcome we want to be able to provide, right? Which is the high SLAs and a credible pathway towards sustainable infrastructure. And so here's a little bit about our team. Company was founded by Raymond Ononiu, who is an ex-Microsoft engineer and has 2 decades of experience in the software and hardware tech sector. And there's myself. I'm primarily from the supply chain sector, focused in logistics for the past 10 to 15 years. And we have come together to be able to now go ahead and create Horus Labs and bring it into the modern data world. And as you can see, we have our team as well listed on the bottom, and our partners from across the board as well. So with Schneider Electric, Control Plane, and NIS Capital, and the AI Hub for Sustainable Development. And so, yeah, with that, I think I know we're short on time, but I just want to let you guys all know that the continent is ready. We are ready to move forward, bringing you quality compute, and more importantly, we are here to make sure that we bring a sustainable and clean power as well to our ecosystem. Thank you.
Thanks so much, Ludovic, and thank you for that excellent presentation. So the continent is ready. That's a great message to end on. And now I would like to hand over the floor to Abdenour Yahi from JA Solar to show you exactly what they can provide to help you with that 2 megawatt hours that you are looking for. Abdenour, over to you.
Thank you, Benjamin, for this opportunity. Can you please activate the camera, please? And please confirm if you can see my screen.
Yes, can see your screen clearly.
Okay, perfect. Okay, so this is Yahi Abdenour. I am the head of technical for Africa region, working with GA Solar. So as we know, GA Solar is a tier 1 manufacturer. We include the full chain value starting from the ingot, wafers, cells, until the PV module, with an annual capacity, production capacity over 70 gigawatts per year for the ingot, wafers, and cells. And for the PV modules, we are over 100 gigawatt per year. And also we have included the BSS product in our product, okay, starting from 2022. And for this presentation, I focus mainly on the CNI application, since the event is focusing on CNI application. Okay. So, yeah, a small presentation by GA. So we had been founded in 2005, and we have a cumulative capacity of more than 317 gigawatts as per Q3 2027. We are covering more than 180 countries, and global market share is 14.5%. And this is related to the PV. And for Africa region, we are the first supplier for 3 consecutive years. For 2025, we made more than 4.7 gigawatts. And in terms of patent, we are at more than 2,000 patents held by GA Solar. Okay, so our global partner for the BSS solutions. So starting with Roche Energy, who is our partner for the CNI application for the 261 kilowatt hour, which I will explain later. We have Megarivo, we use the PCS, which is a very good PCS for microgrid application. Cornex is our partner for the utility scale cells for the 5 megawatt hour solution. Synixel, we are using Synixel for our PCS utility scale application. So as a portfolio for GA products, so we have the utility scale application with 5 megawatt hour. We are expecting to start the 6.25 megawatt hour by the end of this year. And for the CNI application, we have a wide range of products starting from 50 kilowatt, 100 kilowatt hour, 125 to 61 kilowatt hour, and the product can be extended till 2 megawatt hour. Additional to this, we have also residential application. For residential application, we have batteries with 5 kilowatt hour, and we have a new battery with 16 kilowatt hour. And for small residential application, we have also 5 kilowatt hour. It can be extended to 10 kilowatt hour, including the inverter. Okay, so I will start on solutions we are providing, because for GA, we are not only providing products or selling products, but we provide fully integrated solutions for utility scale and CNI industries. So we'll start with the utility scale application quickly, and we'll move to the CNI. So for the best application, it can be added to renewable energy, and it can be also added to conventional energy like thermal power integration solution. And also we can do standalone business solutions. As we see from this schematic, we can do an AC coupling between the BSS application and the wind application, wind solutions, and PV solution. We can do also a genset if it's available, and all this will be connected to the same bus bar with the grid, and we can ensure for this application we can ensure a grid forming solution or grid forming mode and grid following mode. Second solution, which is optimizing or co-optimizer control of BSS and thermal power units to enhance grid ancillary service compatibility and decoupling the control of heat and electricity generation, improve operation and flexibility. So by doing this, we can connect the battery, the utility scale battery, 5 megawatt hour, in parallel with the thermal power integration solutions. So to have to optimize the grid, or to enhance the grid stability, and also for the standalone applications. So where we can target, for example, the self-consumption for factory which is connected to the grid or not. For utility scale, it need to be connected to the grid, or it also can be working off grid because we have the VSG modes. So by doing this solution, or this solution will help to perform the energy arbitrage to mitigate the price volatility and optimize the supply demand balance. Okay, and switching to the next solutions, just a moment. Yeah, switching to the CNI solutions. So for CNI solutions, we have also wide range of product, starting from the 261 kilowatt hour we can see here in this slide. So this application is oriented, or this product is oriented mainly for on-grid application, and we can do the AC coupling with this solution. So it can be coupled to PV, and it can be coupled to genset or the grid. Okay, and we can ensure a seamless switching for these solutions. The second solutions, it's also for off-grid CNI applications, where we can do both AC coupling or DC coupling based on the needed of the client. And also we can do seamless switching between off-grid mode to on-grid mode. And we can manage the different sources. We can have, for example, PV, genset, wind. Yeah, usually we don't use wind for CN application, but let's focus on genset, PV, load, and grid, and we can ensure seamless switching of less than 20 milliseconds for this application. And another application also, which is using another type of product, which is a small product with 645 kilowatt hour. Also, we can do AC and DC coupling. We can parallel till 3 to 4 units in parallel to increase the power based on the needed of the client. And we can also perform the black start capability for the client or the partner application. So I will switch now to a small presentation about the product, since we have made a small presentation about the solutions we can develop. Yeah.
Very quickly, just to give the other presenters enough time, I'd encourage you to wrap up pretty quickly.
Okay. Thank you. So this solution is 5 megawatt hour solution, and we can do 0.5C and 0.25C based on the request. And we have also the 1 megawatt hour. We have also 2 megawatt hour solution. It can work with AC and DC coupling based on the application. And we have also the 261 kilowatt hour, which is oriented for AC coupling systems. And the 120 or 215 kilowatt hour, which is dedicated for small CNI application. And here we can see some BSS projects, which has been constructed through different regions: Europe, China, Africa, as we can see here. And by doing this, thank you for your attention. Waiting for the questions. Thank you.
Thanks so much, Abdenour. And it's staggering the sheer amount of products and the quality of the products that JA is able to offer. So thank you very much for that. Now we're going to move to someone who's on the ground implementing these projects, Swaleh Hassan, working for Gadgetronics. Swaleh, I'd like you to turn on your camera and unmute yourself and share your screen and tell us all about what Gadgetronics does.
Thank you, Benjamin. I really appreciate this invite. Can you hear me? And can you see my screen?
Both are clear as day.
Okay, good. Good to hear that. Yeah. So let me just try to do this. Okay. So my name is Swaleh Hassan. I am the Business Development Manager at Gadgetronics.net Limited, with our headquarters being in Tanzania, as well as I am the Business Director for Gadgetronics Kenya Limited. So at Gadgetronics.net in Tanzania, we are one of the biggest, if not the biggest, project developers, EPC. And then in Kenya, we are strategically doing distribution for the products and solutions that we offer from Tier 1 manufacturers. So Kenya is our hub, logistics hub for East Africa. So we supply and support
Sorry,
into
Swale,
Uganda.
just to interrupt you quickly, can you turn on your camera so that everyone can see who you are?
She's
To the
turned
face
on.
to the voice.
Oh, sorry, can you see me now?
There we
I don't know
go.
what happened there.
That's great. Thanks.
Okay, thanks. Yeah. So are you able to see my screen?
Yeah, everything works. It's doing
Okay.
great.
Yeah. So as I was explaining, Gadgetronics Kenya is a logistics hub into the rest of East Africa, where we support other EPCs and developers and working directly with the OEMs to do this support. Back to where we are. So Gadgetronics was established in 2014 here in Tanzania. We work with, we're a trusted partner. We are distributors of various Tier 1 products and solutions within the energy, water, security, and telecommunication sectors. We are an EPC where we do several projects for different client types or for different sectors, from hospitality to finance, education, humanitarian, and so on and so forth. We also act as consultants in terms of system designs and solutions that we can offer. We have more than, at the moment, we have about, I think, 182 employees with about 70 technicians and about 14 engineers who have different roles, from those who do site commissioning, from the design aspect, as well as our workshop management. Yeah. So as Gadgetronics, the four sectors or the four business units that we have are energy, where we mostly do solar power systems and solutions. We do water, so basically from extraction in terms of borehole or from whatever water source, and all the way to filtration. And then in terms of security, it's basically everything from in security, from automated gate motors, CCTVs, access control, you name it. And then in telecommunication, we are internet service provider for northern Tanzania mostly, as well as we do radio communication. Our headquarters is in Arusha, where in Arusha we also have a warehouse where at any one point we have $3 million worth of stock for different products and solutions. We have a branch, a fully stocked branch, and an office in Dar es Salaam for our coastal region. We have a shop or a showroom in Arusha as well, a place called Njiro Complex. And then we also have a fully fledged office with a full team in Zanzibar to serve the Zanzibar archipelago. And Nairobi, as I mentioned before, that is our logistics hub. So up to date, we have done more than 1,500 solar power plants, especially within Tanzania, across the whole of Tanzania. Basically, I need to update this. We've done more than 16 megawatt peak cumulative of projects. We have done. We have provided 959 megawatt hour of batteries that we have installed. Yeah, so we do both off-grid and grid-tied solutions, as well as battery powered backup systems. We have DC refrigeration from coolers, chillers, and commercial systems as well. We also work directly with power generators or diesel generators, if you may call them. And we do hybrid systems, but we are not in the wind and hydro sector yet. And we are not looking into that at the moment. And then we also have, for the smaller systems, we have portable power solutions. Yeah. So some of the energy projects that we've done is Kubu Kubu Tinted Lodge, where we have about 212 kilowatt peak with a 400 kilowatt hour of storage using two times 100 kilowatt inverters. Lahia Tinted Lodge as well. This is in Tanzania. It's in Serengeti. We've done 174 kilowatt peak by 150 kilowatt hour. This is a bit of a microgrid where we've combined also with grid-tied inverters, which feed off the voltage of the existing battery system. Then we have Main Chen Chen Lodge. Sorry, it's happening. Yeah, Main Chen Chen Lodge, which has a 200 kilowatt hour system, but at the moment as we speak, we are upgrading this lodge to 600 kilowatt hour. We have Saadani Kasabe, which is in the coast. This has a 100 kilowatt hour system with about 60 kilowatt peak. And this one as well, we are upgrading to 300 kilowatt hour as we speak. We're just waiting for the battery to come in so that we can go work on it. We're in the mobilization stage at the moment. Yeah.
It's time to start wrapping up.
Okay.
Thank you.
Thanks. Yeah. Some of our product and solutions partners who we work directly with, we have Freedom One from South Africa. There's batteries built in Africa, meant for Africa. Fronius, Ates, Jinko Solar, you name them. And there's just, I would say maybe even 5% of the clients that we have, including Pepsi, Hans Paul, and the likes. Yeah. Thank you so much.
Thank you so much, Swale, and great to see more of an overview of what Gadgetronics is up to, and I look forward to the discussion with you later. Now, last but by absolutely no means least, we have Adewale from Royal Power and Energy, who actually has experience in doing EPC projects for data centers. Adewale, please unmute yourself, turn on your camera, and begin your presentation. Thank you.
Hello, can you hear me?
I can, but your presentation is in the presenter mode, so we can see all your speaking notes.
Oh,
Perfect. Away you go.
can you still see the notes, or are you fine now?
No, it's fine now. It's showing normally.
Okay, all right. Thank you, everyone. I'm glad to be a part of this panel. I'm just gonna try and skim through because I know we're really pressed for time. But my name is Wale Odugbeso, and I'm the CEO of Royal Power and Energy Limited. We're out of Nigeria. We're a blend between EPC and OEM, depending on the solutions that we provide. And we're focused on pretty much the telecoms, banking, and CNI industries. And I'll carry on here. With this presentation, the reason I wanted to anchor the conversation in critical loads is very straightforward. They're the most demanding off-takers that we've seen on the continent, based on our experience. If you're able to pretty much provide solutions for data centers, banks, or the telecom customers, you're pretty much able to provide solutions for anybody else within the market. They have zero downtime expectations, and as a result, there's sort of like zero tolerance for skipping or unplanned downtime. There's three perspectives on every single project. There's the OEM, there's the EPC, and there's the off-taker. The OEM is obviously optimizing the product spec. The off-taker is optimizing operational outcome, and the EPC, which we are in this case, is the one who has to make sure these two things meet on site in real, ambient conditions with real grid quality under operational constraints. Most project disappointments don't come from bad technology at all or bad clients. They come from the three corners of these triangle never quite aligning on the same operational envelope. I want to be careful here because I know we have a number of OEMs, within the panel, so I'll be precise. This isn't a criticism of OEMs. The spec sheets do exactly what they're meant to do. They describe a product under reference conditions. The issue is African deployment in our experience, right, almost never refers or has a reference condition. Ambient temperatures usually regularly run 10 to 20 degrees above spec. Grids are very dirty. Every site needs some sort of real civil and electrical adaptation. Spare parts are subject to FX and customs as we have in Nigeria. And integration with whatever legacy infrastructure the client already has, a UPS, BMS, SCADA systems, is quite difficult. This is the gap the EPC tries to close, and it's why a project looks straightforward on paper and often really isn't during deployment. Critical loads really change the engineering. Generic and commercial and industrial solar plus BSS systems are forgiven in the CNI space, as I said, but critical loads are not forgiven. You're integrating with a UPS that might be older than your BESS, and you're slotting a redundancy architecture with the client. The client has built around their compliance requirements. You imagine the transfer times measured in milliseconds and harmonic dislocations limit tighter than the grid that you're tying into. These aren't theoretical concerns. They're pretty much practical limitations that we've seen on sites in trying to deploy to a number of data centers. So where do we actually save the client money from an EPC perspective? There are five, places that we've listed here, and these are not theoretical. And I'll go through each one. Right sizing rather than catalog sizing or generic overspeccing can, in our experience, has pretty much saved, between 15 to about 30%. Logistics and customs, pure operational expertise can save you another 5 to 10%. The balance and plant value engineering, the cables, the switchgear, the civil works, are a third, probably about 30% of the project cost. And this is where, we almost insist with any sort of deployments that we're doing that we are included at the design stage of any solution that has to do with BESS or integrating into their power system. Blended sourcing, I know a number of OEMs would not want to hear this, but, a single vendor sourcing is easier, but over the long run seems to be a lot more expensive and less resilient. And finally, O&M architecture, decided that procurement, not retrofitted, is probably a key perspective. This last one, the OEM design is the biggest cost lever in a solar plus BESS project, and it's one that is most often skipped. I want to spend a minute just on something that I think, changed the way we think about EPC delivery. We built our own internal intelligence platform. It's called Debeji, because the alternative was operating our fleet blind. The solar plus storage assets in Africa fail in ways that single site monitoring just doesn't catch quickly enough. So what our intelligence platform does is it takes a huge number of different assets that we're monitoring, put an AI level on that, and it can predict or determine if there's going to be a failure based on what is learned from one and using that on another site. This has, helped us sort of save about 37% to 40% downtime in a number of the data center deployments that we've done. If I had to compress everything that I've said into one thing, it would be, this is it, none of the individual deployments is about technology. The technology is solved if LFP works, grid forming inverters work, integration is a known engineering problem. What separates projects that succeed from projects that disappoint is whether everyone has agreed on the real operational envelope before procurement actually happens, whether the contracts put each risk on the party in the best way to manage it, and third, whether OEM is treated as a design input from day one, fleet level intelligence, not just single dashboards that bolted at the end. If we get these three things right, the technology will always perform. If we get them wrong, there's no amount of premium kit that will actually save the project. I'll close where I started. The session is framed as a dialogue between OEMs, EPCs, and off-takers. And that framing is exactly right because none of the three can deliver a working solar BSS asset alone. The technology won't deploy itself. The off-taker can engineer their own integration. The EPC jobs is to make the dialogue translate into an asset that actually works and performs over 10 to 15 years of operation. That's the bridge. Thank you for listening, and I'm happy to take any questions that follow.
Thank you so much, Wale, for that excellent presentation. Before, well, to echo what I was saying, if you have any questions, please do not be shy. None of our panelists bite. Do put it in the Q&A, and I will be happy to address them to the panelists. But now, can I ask all of the panelists to turn on their video and their audio, because I have a few questions of my own that I'd like to ask you. So, as far as I'm aware, none of you have worked together on a storage project. So, to open this, let's be honest about where we are. So, Ludovic, Horus Labs is building data center infrastructure where power is a fundamental input, not just a utility cost. And for you, has behind the meter storage come up seriously internally? And if so, what has happened to that conversation?
Yeah, actually, I mean, originally we were only looking at a PV array, just because of the cost of putting in, behind the meter storage. But as we look at the grid, I think while I was mentioning about, the grid can be dirty, and I think one of the slides even had, harmonics issues. And this becomes a reality for us. And in the data center space with really high SLAs, we can't afford that downtime. Downtime can be as low as $1,000 an hour to upwards of $5,000 an hour, depending on who your client is. And so taking on that risk has other impacts that far exceed just the investment of the battery system itself. And so all of a sudden now it becomes a crucial portion for us to not only have the storage, but also be able to ensure that, we don't have these other hits coming, to our business, right?
No, that makes sense. So as you've kind of shown, storage is one part of the solution and overall, but yeah, that's interesting to hear. Abdullah, so African C&I loads are at the best of times, let's say, unpredictable. There's variable grid quality, motors, compressors, frequency outage. So when sizing a behind the meter system for that environment, how much of the real design challenge is actually the battery versus everything around it, the inverters, the protection, the monitoring, and is there something that clients fail to understand about that until it is too late?
Okay, thank you, Benjamin, for these questions. So for the design of CMI solutions, we need to take several parameters in consideration. So first of all, we need to understand what is the load of our client. So usually we advise the client to share or to install a data logger, millisecond data logger. At least we know what is the profile of the load which is installed inside for the applications. And to know if there is some inductive loads like motors, what is the inrush current? Can the inrush current supported by the inverters, the PV inverter or the PCS? So those kind of parameters are very important for the design of CNI solutions. So based on the data given by the client, so we start analyzing what is the data of that application and advise which product or which solutions need to be installed or match that applications. So for example, if the client have motors and inductive loads with high inrush current, which cannot be supported by the PCS, or it cannot be supported by the inverter. So in that case, we need to install a VFD to avoid having inrush current, which cannot be supported by the PCS. So for the battery itself, there is no impact of that kind of load, but mainly the discussion will be related to the power electronics, means the inverter, PCS, EMS, how it's managing the different sources, okay? And the second point is how the grid stability is, how the imbalances of the voltage is, okay? So all these points need to be taken in consideration when making design. And based on that, the correct equipment will be selected. And after that, we will double check, after installing the equipment, we will double check in the commissioning how the system is performing and which configuration need to be adapted to ensure that the system is working with ensuring the stability of that application.
So that's interesting. So from what I understand from you, it's a kind of iterative process. You find the data that the client gives you, the load, and then you design something for that, and then you kind of iterate and iterate and iterate to kind of perfect.
Yeah, exactly.
Slowly. No,
yeah,
okay,
exactly. Because here we are having non-linear. We are having non-linear load, okay? With including the power electronics, you will have a lot of harmonics. So you don't have a predictive model to work with, okay? There is a standard process you need to follow, but need to adapt based on the application of the client.
No, thanks for that, Abdul. Well, there's a question in the Q&A that ties in pretty nicely with a question that I have for Swale. So Swale, once a system is commissioned and you've left the site, what does ongoing performance monitoring and O&M, including procurement of spare parts and so on and stuff like that, look like in practice? And is that a service that Gadgetronic provides, or does it subcontract, or does it leave it to the client entirely?
Well, for us, once we leave site, we take it as basically commissioning is just the start. Okay, we prefer to handle O&M or operations and maintenance ourselves using our dedicated internal teams. And this is just to ensure the highest standard of care for the system that is in place. For sites within our primary regions like Tanzania, our teams usually performs all the scheduled maintenance. And then for projects outside Tanzania or Kenya, if we need to optimize maybe O&M cost for the off-taker, we may subcontract this service to a seasoned professional local EPC within that region. However, we ensure always that a Gadgetronics engineer is always present to oversee the O&M work. And I believe with this hybrid approach, it's far more efficient than maybe mobilizing our own team while still maintaining our strict technical quality standards.
No, thanks for that, Swale. And then with the specifically on spare parts, because in projects in Africa, most of them have to be imported from somewhere else. Do you have a kind of a basic SLA for how long it will take to get spare parts to a project if needed, or anything like that? Is there anything you can tell us there?
Yeah. So in the last 2 years, what we have done, since we are also distributors of this BESS solutions and everything else, what we have done is whatever order we make, whether it's for stock or maybe there's a huge time in terms of the procurement phase, we always make sure that we order the most important spare parts within our consignment. Okay, so when we do a project, we already have the spare parts in stock. So this plays a lot when it comes to the downtime. If it happens, we always pray it doesn't happen. If a site is down, we always have the spare part in stock in our warehouses.
No, thanks so much for that, Swale. And I think it's important to take that into account whenever looking at a project. But so, Wale, there's a question in the chat that probably fits you best, although the person hasn't necessarily put that it's addressed to you. I'm going to address it to you because it fits in with this kind of the role of monitoring and asset intelligence in Solar Plus BESS critical load deployments. And in remote locations where network signals are poor, how do you ensure remote monitoring is efficient, and what fail-safe methods do you have? And also, kind of from your perspective, what does best-in-class operational visibility look like for a data center client, and how does that change the conversation between EPCs, O&Ms, and off-takers over an asset's life?
Okay, so yeah, I'll start with the more difficult one, right? The in remote areas, what we found, because we have probably about 20,000 installations around Nigeria. So some are obviously within the urban centers, some are in remote areas. And yes, the networks there are quite choppy. But the way we've worked around that is we record all of the and I don't know how technical I want to be, but we basically record all of the issues that are happening at that site, and we can then pull them up into the cloud whenever the network actually becomes available, right? So we then store them locally within each of the sites, either a monitoring platform, right? And then once there's even a ability to sort of like push that up to the cloud, we then push that. So that in some locations might give you a lag of, as opposed to it being real time, maybe it's it's maybe an hour or 2 hours behind. What we've also done is on some other sites, we actually use satellite communications, which are not reliant on the networks, within your BTS sites or your telco networks in country. So we just actually put those directly up to satellites, and then like the way what's it called? Elon Musk's sort of internet provider, right? Starlink pretty much works. So we have those two options depending on the client that we have. And in terms of remote monitoring, what we saw with a number of data centers, remote monitoring platforms, is they provide strictly alerts, right? And they only tell you what has happened on site, right? And that's why we built Dibeji, which is our internal AI-powered monitoring platform. And what that does is, for Ludovic or for any other data center operator, he might have certain alerts that he wants to see versus what what another data center operator wants to see. So if Ludovic wanted to see what the ambient temperature, if it's gone up by 2 degrees, right? But another client only wants to see that happen if there's been a power outage. What we've been able to do on Dibeji is customize alerts, right? So you can type in real language, right? I want to see an alert that tells me if the ambient temperature has reduced by 0.5 degrees, and it will send you that alert, right? And if there's anything that actually goes on site, right, we are able to diagnose and provide recommended steps, right? So we are the EPCs, but we can also say, look, this is on the monitoring service is completely different, right? So we will say, all right, okay, from what we've seen, your performance has gone down by X amount, right? And assessing all of your installations, this is exactly what you need to do to be able to rectify that. So we can diagnose and rectify or provide, remedial steps on how to improve that issue.
That's I, I think that's really interesting because it's going back to what you were saying in the presentation, where the off-taker wants a kind of single point of contact or single point of responsibility to be able to handle all these questions. But speaking of off-takers, Ludovic, I can see you nodding along there to most of what Wale was saying. But so I want to ask you a question before we start moving towards the close. Pull the curtain back for us a second. When a storage proposal arrives at Horus Labs, what does the internal approval process actually look like? Who needs to sign off? What financial metrics do they go straight to? And perhaps most crucially, what would most likely kill the conversation before it reaches a decision?
It's a great question, and I think it's one that is yet to be resolved in a clear manner, at least for operators like us, right? Because we deploy not only the data center in this case, but also the IT hardware. For the internal approval process, I mean, we have our internal team. I think we're a small team. I think you might have seen it on our slide, but we do have our financiers, and so here, this is where the challenge arises. From our side, look, you have when the storage proposal costs, storage is expensive still relatively when you compare it at least to the PV array itself. And the first thought process is, why are we paying for this? If your grid is decent enough, what is the value? The value often for us is, well, and what we try to present is, well, not only the storage aspect, like we've mentioned a few times in this call, but it's how do we go ahead and see the other value, the indirect value, and bring light to that. And this is a very nascent conversation, I would say, in the space, even with the level of financiers that we have. But it is a lot of this is like showing, okay, let's look at some of these sample offtake agreements. What are the terms and conditions? What are the charges that are related to this, and how expensive can this become? Because you may have one client today that has a pretty high liquidated damage charge, but what if you have a great contract coming up and it has an even higher charge, right? What do you do then? And so these are the conversations that often come up. So, but I would say if there's anything that kills the process from the get-go, it would be that, yeah, where the price is absurdly high, right, where we cannot justify it with any means possible. That's one. The good thing is that battery prices have been coming down to some extent, right? So that helps. And then the next bit is, well, the responsibility as well, right? So if you have an EPC who completely wants to just sell and walk away, then obviously that's going to kill the decision process, right? You want to be able to have someone you can work with, and where there's a relationship that allows some sort of risk mitigation going forward.
No, thanks, and thanks for that. Thanks for that honesty. You're kind of stuck between a rock and a hard place. Your finances are asking for value for money, and you're also looking for what extra value, that sort of intangible value that storage could bring to you.
To be fair, the key thing that's hard here that we're in a new epoch, right? This is a new era where many finances are not used. There's no previous cases to look at, right? At least not many, especially in our region. So this makes it even more complex, right? And it's like everyone wants a comparable. And so if you don't have the exact comparable, then it takes even more skill on, say, the investor side to be able to understand the risks at hand.
So I suppose as a kind of follow-up and closing question before I go for a last remark for everyone else, basically, does anything that you've heard from our EPCs, our OEMs that are present on the panel today, does anything that you've heard get you closer to to procuring a best backup system for Horus Labs, or was this something that was always on your radar anyway?
This was already on our radar, and I think that's the key thing. Yeah. So we've already had an EPC who quoted us, and we've been comparing some of the metrics that's been coming from the customer requirements, and this is how we've come to this decision, right? Originally, it was only to have a PV array, but given everything that we've spoken about, not just myself, but the rest of the presenters as well, the BESS system does look very interesting, right? I think then it's just a question of agreeing with the financiers on, okay, how much storage do you put in, and who's comfortable with what, right?
Right. No, I think that's just to bring it round to the other panelists as well. I want to get your final thoughts and sort of really one quick thing. You've heard basically throughout this what a serious off-taker such as Horus Labs and Ludovic actually needs. Can you each give me one practical thing, not really a policy ask or a technology breakthrough or whatever, but one practical thing that would move the needle in the next 2 years for BESS and CNI customers, and you having more access to them. So I'd like to first go to Abdul for your very quick thought on that.
Okay, so yeah, can you please repeat the question, please, Benjamin?
So you've been hearing from Ludovic basically what a serious off-taker actually needs, right?
Yeah.
And now, can you give me one practical thing that would most move the needle for BESS for CNI in the next 2 years, from your perspective?
Okay, perfect. Yeah, so based on the CNI application using BESS, so the integration of the BESS has changed let's say the CNI application significantly, because previously we were using the PV plus genset, or PV plus grid, but with the introduction of BSS, especially with the seamless switching, so this has given another stage of operation, okay, because you will be able to operate without noticing any cutoff from the grid. And even if the SOC of the battery, let's say, is less than 20%, your EMS will be able to start the genset or to start another sources which is available there. So what we are looking for within the next 2 years is firstly increasing in the power density of the battery itself. So now moving from 280, we are at 314, and we are expecting more power density for the battery, and also improving the protection and the cooling system of the battery to be sure that we are more than 100% safe for any application.
Thanks so much for that, Abdul. So improving the energy density. Swale, I could see you nodding your head there. Do you want to give your final 30-second soundbite of what you think to that? If you want us to hear it, you have to unmute yourself.
Sorry about that. In terms of moving the needle, I think in some aspect we're already seeing it with some of the tier 1 manufacturers. For example, we now even have solutions for 0 milliseconds, like something just like the UPS functionality by using a rectifier. However, I think standardization of maybe integrated product package, if we could align maybe on a modular plug-and-play design frameworks where the hardware, the software, in terms of monitoring and financial contracts are privated, we could cut probably the project cycle by 30 or 40%. That operational simplicity backed by a team that can execute on the ground, is the key to scaling from pilots to regional rollouts.
Very clear. So kind of pre-installation and modular installation being possible to speed up the deployment. I think that's good. And Wale, we'll come to you as well. Your 30-second take on what's going to move the needle in the next 2 years.
Yeah, thanks, man. Look, I think it's probably the most boring answer I'm going to give here. I think the single most practical thing would be a recognized industry standard for handover documentation, right, on solar plus BESS for critical loads. And I'll explain. Today, every EPC hands over a different document set. Some are thorough, some are minimal, some are great on commissioning data, but others are weak on, say, as built drawings, and others are reverse, right? The off-taker has no way of comparing across vendors, no way to verify what they're given is complete, no way to audit a performance against what the original commissioning baseline was 2 years later, right? So if the industry, and I think this has to be largely driven by the off-takers, right, agreed on some sort of minimum standard handover nodes, right? For critical load BTM systems, every project quality would literally step up overnight. The good EPCs like ourselves already do this, but I think for the marginal ones, when we have to go in and try and figure out what they've done wrong, when the client then calls us on an already established solution, it makes it very difficult for them to actually pinpoint what the gap really was.
No, I think that's absolutely vital. The kind of industry, at least best practice, if not a legal standard, or anything like that. Well, thank you, all of you, and thank you for your time this morning. It was a really good discussion, and I think one worth having. And hopefully, this won't be the last time you discuss with each other in this type of context. So, thank you very much to our wonderful speakers, Ludovic Bernard from Horus Labs, Adenor Yahi from JS Solar, Swaleh Hassan from Gadgetronics, and Adewale Odugbasan from Royal Power and Energy. Thank you very much. Now, don't go anywhere, because we have another fantastic panel for you coming up, focused more on the utility scale side of the equation. But for the panelists now, can I ask you to turn off your cameras and mute yourself, and please do stick around for the next panel. Okay, so as we all know, Africa is blessed with all manner of natural resources and talent, but too often potential is held back by power infrastructure constraints. Now, integrating serious shares of variable renewable energy into Africa's transmission grids is absolutely necessary to drive green industrialization and sustainable economic growth across the continent. This is no mean feat, and can place a strain on grids that storage has a part to play in alleviating. However, this requires developing cooperation and understanding between grid operators, OEMs, and project developers around their respective requirements. I'm thrilled to be joined today by senior staff from 3 grid operators across the continent to engage in a discussion with a storage OEM and a project developer. So I would like to welcome our speakers today, Claver Gakwavu, Acting Managing Director from Energy Utility Corporation Limited of Rwanda, Klopsile Klofe, System Planning Engineer from Eswatini Electricity Company, Mfaiza Firi, the Senior Manager Renewable Energy Projects for the Zambia Electricity Supply Corporation, and Titus Koek from ESS, Head of Technical for Middle East, Africa and Central Africa from Jinko ESS, and Laurent Roineau, Chief Technical Officer from AFSIA Energy Cluster. Welcome to you all. So before we kick off the discussion, similarly to last time, I'm going to invite our esteemed speakers to make several quick presentations, particularly from the grid operators, on how their grids are operating so far and what they think of storage. So without further ado, I would like to hand over the floor to Claver from EUCL in Rwanda. Please turn on your camera, unmute yourself, and share your screen. The floor is yours.
Thank you very much, Benjamin. As you already started, my name is Akleva Gakwavu. I'm the MD of EUCL. EUCL is Energy Utility Corporation Limited. It is a subsidiary of Rwanda Energy Group. It's the utility is vertically integrated and acts as a single buyer. We basically have various players as independent power producers, and we are a single utility that buys and sells electricity to the final consumers. And I was happy to join a bit earlier, and I had most of the interactions were around how the solar and technology around it is basically shaping the entire continent, but also broadly changing the overall setup and structure of energy systems because of what it brings on board. And this is how the presentation is going to be structured. As already mentioned, we are part of a bigger market. REG is a holding company that has got two subsidiary companies. One is EUCL and EDCL. EDCL stands for Energy Development Corporation Limited, while EUCL is Energy Utilities Corporation Limited. We belong to the bigger Ministry of Infrastructure, that hosts almost the bigger economic drivers of the economy. They have transport, they have energy, they have water, roads, and sanitation as well. So, as mentioned, utilities, maybe focusing on the utility, it operates generation infrastructure, transmission, distribution, and does retail, whereas development is more or less of a budget agency, but also a development arm of the group because it is now venturing into other markets. But it is also kind of a vehicle where government channels the capital investments or subsidies to the utility, where most of the infrastructure developments are done on as capital subsidy to the utilities, so that the end user do not entirely pay a return on investment to the utility through a tariff. So that's here I'm shedding more light of how we are structured. We have Ministry of Infrastructure, which is policy oriented and does monitoring and evaluation. They also assess the way we perform so that they avoid any gap of what is done at an operational level and what is expected at the policy level. Then there's Ministry of Finance, which mobilizes adequate financing, uh, uh, does audit to ensure that there's value for money on the capital spent, but also make sure that they kind of introduce necessary reforms to ensure that we align to the global picture of the country and also the expectations. They also serve as the main ministry, actually, as the shareholder for the company, because however much we've been almost 100% owned by the government, by the companies operating as a private company, which provides a bit of flexibility, in day-to-day operations. Then we operate in the regulated markets. RURA is the regulator, whereas RDB attracts financing, rather attracts the investors, but also is the chief negotiator for most of the people that or the investors that interact with through public-private partnership. Reg and subsidiaries that translates policies into actions. So in the earlier discussions, I think most of the discussions are basically addressing some of the critical concerns of a system operator, because as a system operator, you have so many elements in the system that translate themselves as demand, and what you monitor is more or less frequency, voltage, and so on. But the system itself is complex. Whether the area issues of inrush current that are being mentioned, be it reactive power management in the system, But what you want to achieve in the end is to make sure that you balance your demand and generation, and therefore you avoid a situation where a single incident in the system would end up affecting a bigger part of the system, or even risking and interrupting the entire system. Here I'm sharing a bit of the situation on the African continent, which is an opportunity for solar and solar companies, especially combined with battery, that becomes a bit of a solution to the critical challenge that Africa is facing in general. So when you look at the current gap of close to 600 million people in Africa without access to electricity, and on the global scale, almost 8 people. When you basically have 10 people out of the 8 people on the African continent don't have electricity. So when you have a lot, kind of 10 people standing in one location, 8% of those that if at all eight people are not to have electricity, 8 of them would be belonging to the African continent. On the sub-Saharan reality, access globally stands at a lower rate compared to 78% in urban areas. Rural is quite shocking in terms of percentage, 28%, whereas rather urban stands at almost 78%. But you can imagine 806 million, 600 million people without access to electricity, 28% that don't have access, that have got access to electricity. And even in the cities, the so-called, the kind of cities that have got infrastructure, that have got all that would be required to live a decent life, most of them also don't have access to electricity. And this is quite a significant opportunity for a private sector to support governments in ensuring that everybody is connected. In terms of renewable minority, however much Africa has got a significant potential for hydro, but hydro represents only 17%, which is considered to be exploitable or exploited, whereas solar and wind combined accounts to less than 3% of the historical energy supply. So the part is that however, Africa is considered to be a sun-rich continent, but in terms of potential, that's got close to 11 terawatts or 60 million terawatt hours in terms of energy. But when you look at the pace of exploitation or utilization, less than 3% of the global solar generation has been for solar has been exploited, whereas for hydro stands around 6 to 7%, 5 to 6%.
Can I
Correct.
encourage you to start making your closing points, please?
Okay, thank you. So, and I indicated a bit of initiatives on the African continent. I'm indicating the rising consumption in Africa. I've mentioned some of the percentages that indicate how the Africa stands, and the growth is however much it is considered to be growing. But remember, there is a bit of a suppressed demand, and also there are some of the areas that haven't even been able to get access to electricity. And bridging the gap, indicating some of the solutions that could be exploited. The presentation is going to be shared, and I probably, without going into the details, I think the best way is to ensure the presentation is shared. Here I'm giving a bit of an example of how Rwanda stands. Access to electricity, we currently over 85%, which is quite a significant progress compared to other sub-Saharan African countries. But in terms of today's discussions in terms of hydro and solar, you can see that solar we are quite doing well, but in terms of solar, the percentage is quite low, almost 1% for solar in terms of actual available capacity, whereas in terms of installed capacity, 4%, but available capacity that significantly reduces. The good news for private sector is that the market is open in terms of policy, regulation, and everything is in place. The government actually has recently, in the new policy, opened up for captive power to make sure that they don't over-regulate on the new entrants into the market to help the government be able to achieve 100% universal access, but also address issues of reliability concerns. And here I'm just indicating how the market is wider. Yes, you may be positioned in Rwanda, you may be positioned in Rwanda, in Kenya, Ethiopia, however, but you have access to the bigger market. Thank you very much. I will stop here and be ready to answer any follow-up questions. Thank you very much. Appreciate it.
Thank you so much, Clever, and we will ensure your presentation is shared with everyone else. Thank you very much for that. Without further ado, I would like to call Klopsile from the Eswatini Electricity Company as our next presenter. So, Klopsile, if you can unmute yourself, turn on your camera, and please share your screen so that we can see your presentation. Thank you.
Good morning, everyone. I hope you see my presentation.
We do, but it's not in presentation mode yet.
Okay, thank you.
Perfect. You're good to go.
Okay. Thank you so much. Thank you so much for AFSIA for giving us the opportunity to be part of this dialogue of the IE conference on storage solution. My name is Klopsile Hlophe. I'm a system planning engineer at Eswatini Electricity Company. Mainly for Eswatini, when it comes to storage solutions, we are still at development stage. But my presentation content will be based on the high level of what EEC operations are and the generation that is currently installed currently. And also, I'm going to talk about why do we want to incorporate BESS onto our grid, like the energy storage, the battery energy storage, and what is the implementation roadmap, and also look at the proposed deployment strategies and also advise how to integrate to the grid and what are the policies and regulations, instruments that are there for us to support any developer. Mainly EEC is a vertically integrated government-owned power utility. We still bundle it that we transmit, we generate, we distribute, and also we have our trading platform. It's still within the EEC structure, and our customer base is around 313,000 customers. Our population is about 1.2 million. We are a landlocked country. We are just a small country of about 17,000 kilometers square, and our demand as Eswatini is about 255.5 megawatts, of which the energy demand equivalence is about 1,195 gigawatt hourly. And also, we are highly dependent on imports as Eswatini. Since we have just alluded that we are a Eswatini landlord country, most of our energy, we take it from neighboring countries under the SADC regions, according to the different bilateral agreements that we have. Currently, our installed capacity, we've got mainly hydro, which is about 60.5 megawatts, and also we've got our solar PV plants, which is about 10 megawatts, and it's also about the rapid integration of embedded generation, but that is a small scale. It's not the utility scale, but we've got only one utility scale, 10 megawatts. And also we've got a 1 megawatt BESS, which we normally use. The model is a peak shaving model for that 1 megawatt BESS over a 4-hour dispatch period. Then Eswatini, as you have seen, that we are highly dependent on imports, highly dependent on a supply of our energy from other SADC utilities due to the different bilateral agreements that we have. So now as Eswatini, we are developing a BESS terms of reference just to support the key challenges that we are facing as Eswatini EEC. As I've said, that we are highly dependent on imports. There is a supply risk that we were looking at as a planning to mitigate those risks, and the prices that comes with when we are depending on other people's import of energy. And we've also seen that because we are also supporting via the regulator a platform of Eswatini, we have also seen a rapid change in our generation, in our energy landscape, incorporating some embedded generation. And we also have plants that are going to be integrated into the grid. I think by year 2027, 75 megawatts of solar PV plants that are being developed by the private sector via the energy regulator bidding window. And we also want the key challenges that we also see as Eswatini. We've got a big challenge of maybe in the north part of the country of a low short circuit ratio due to the lengthy lines of our transmission, especially the 66 kV lines. So which comes with the voltage instability into that part of the network. So we want also to help to boost the voltage stability and the solar intermittency impact that comes with the 75 megawatts, because mainly for Eswatini contents for BESS is going to assist us with load balancing challenges to avoid the penalties of emergency power bilaterals that we get from, since we're the affiliate of SAPP. So we want to also to mitigate that. That's why we opted for the solution of BESS. BESS comes with a lot of dynamic support. BESS comes with a lot of dynamic benefits for us. That's why maybe we've developed the terms of reference to incorporate maybe some some storage, energy storage into our grid as EEC. So maybe firstly, it cannot be like the benefits that are going to get frequency response regulations. Maybe that dynamic model as EEC, as Eswatini, we cannot like say is a high priority for now, because our inertia is we've got a strong inertia due to our interconnection from South Africa to Maputo. So we cannot even say that it will be a priority for us to incorporate grid stability benefits for that. But we are looking at the future if maybe the manufacturers, while we are installing the BESS, it can come with the dynamics control aspects to assist us maybe in the near future. But then what we are looking according to Eswatini contest is for voltage support and reactive power control into our network, and also to support the renewable integration. As I've said, like we're about to integrate like into our grid 75 megawatts. So we need that support that will be supported by the BESS integration. And also the peak shaving, as I've said, we are highly dependent. Our peak is in the morning and in the evening. So we need that to support the peak shaving to avoid the high cost that comes with the hitting a different peak demand from our different bilateral agreements. And also the load management to avoid the load management scenarios for the country, to make sure that there is high energy security, and also to support the grid resiliency and stability. As I've said, Eswatini have gotten implementation roadmaps. We have developed terms of reference, but currently we said, like, as much as we know that our grid, what does it require? We know what are the pros and cons of our grid, but then now let us start at the concept stage. We've developed terms of reference. That is our roadmap currently that we are having. We are saying, let us do a feasibility study. as much as I've said, like we've got a solar plus BESS, but it's a 1 megawatt hourly BESS. It doesn't have the different dynamics that when we are looking at our grid, when we are planning our grid to improve the reliability and resilience, it only does the peak shaving only that we have the 1 megawatt. But now we want to see the different dynamic models that are being manufactured to support the grid when we are incorporating BESS into the grid. So now currently we are at feasibility. We want to do the feasibility studies to support that, to make sure that we do the geographical site selection properly, and also to see the financial impact, because we know that BESS is very, very expensive, especially at utility scale. It's a very, very expensive technology. And also, is it economic? Is it economical?
If you can start wrapping up and making your closing statements, that would be great.
Yes. Then we are looking for that as a utility. But then this is how we want to propose our deployment strategy on the different solar PV plants that we've implemented in Eswatini. Then I would like maybe to also advise the developers that are going to integrate into the network. We've got the regulatory instrument in place, the Electricity Act, and we also for successful integration of their plans. And we also have a Eswatini grid code, the different grid code components that are there to support you to integrate, and also the wheeling framework, the IPP policies that we have, and also the licensing structure from the ministry and the regulator. Thank you so much. I think the time is against me, but the most important part of it, you need to have some early technical engagement to support developers for them to be able to integrate successfully their BESS if you want to be a developer to support Eswatini energy security. Thank you.
Thank you so much, Kovsile, and it's great to see the work that Eswatini and Eswatini Electricity Company is doing to take advantage of BESS now. So for our third presenter, I'd like to invite our final grid operator of three, Mfaisa Firi from ZESCO in Zambia. Please turn on your camera and your microphone and start sharing your screen. Thank you very much. We can see you, but not your presentation. There we go.
Okay, so good morning once again.
Sorry, if you want to just put your presentation in presentation mode, it would be a bit easier for everyone to see the work.
Okay. So my name is Mfaisa Firi, Renewable Energy Projects and Planning Senior Manager. So for ZESCO, like majority of the power utilities, is a vertically integrated power company. It's involved with generation, transmission, and distribution services. So Zambia as a country, about 2020, embarked on developing what we call an integrated resource plan for the energy development in the country from 2020 to 2050. And initially, when we were doing the demand assessment as well as the load forecasting, we saw that our country demand profile would increase from about 2.5 gigawatts to about 10 by the year 2050. So that entailed that we needed to plan now for generation assets that would respond to the growth rate that was envisioned. So further to that, the IRP also went to studies to try and see how both VRES and the BESS would contribute to the demand, to the generation forecast. So according to the RRP, we ended up having a VRAIS penetration of at 45% of the installed capacity at 2050, which was close to 12 giga. Yeah, so to ensure that the flexibility was there. Sorry, I've skipped a slide. So storage as well as solar require the support of the external grid for frequency and reliability, as has been alluded to by previous speakers. So integration of both the battery and the solar systems required us to do a number of these. So we went ahead and looking at the grid impact studies that we needed to do with the integration of both the VRAIS and the BESS. So we created a framework for the grid impact studies that speaks to the load studies that you have to do, the transient, the short circuit analysis that you have to do, the low voltage right through and the high voltage right through, as well as the reactive power capability compliance assessments. And so ZESCO ended up developing the TOR in terms of reference, updated the grid code, which we have for 2026. It was assented to in Parliament some couple of months ago. And we use the SAP guidelines to ensure that because we, like Iswatini, we are also connected to the SAP network. ZESCO is a SAP member. So in terms of what we focus on as a utility, we want your equipment, either a solar system or the batteries that you want to introduce into the grid. We want to do studies on your own. Then you bring them to ZESCO for review and approval. So because of the manpower staffing arrangements for us, we prefer that you hire a consultant who does the studies for you. Then after you do the studies with your consultant, we'll obviously give you the case file of our work. Once you do the studies, then we'll review and approve if they follow what we have laid down in our terms of reference. If there are issues, we'll tell you to adjust. But essentially, the reliability guidelines are what ZESCO worries most about. So there's a commitment to enabling sustainable renewable growth in our country. And everyone who's willing to participate as an IP is very much welcome for reliable solar systems as well as the storage in Patreon. So we use their standards from the NEC standards to our own grid code. Thank you. So any questions, I'll be able to answer.
Thank you so much, Mbaisa, for that excellent presentation. We're going to head towards the panel discussion bit now. So can I ask all of the panelists to turn on their cameras and open their mics? Oh, sorry. I've realized I've missed out a presenter here. Sorry, incredibly rude of me. But next we have Laurent Roineau from AFSIA, who's going to share the perspective of people deploying projects. Apologies, Laurent. Please go ahead.
No problem, Benjamin. Can you see my sharing?
Yes, clear as day.
Excuse me, just the time to do this. Yeah, so every Good morning, everybody. So I'm Laurent Renaud. I'm the Chief Technical Officer of AFSIA Energy. Thanks to AFSIA team for having me today on board. I would like to share with you the developer's perspective, not as a manufacturer, not as a financier, but as people, as a team that is on the floor, on the ground, identifying projects, structuring them, and living with the realities of the African energy market every day. We're going to talk about the PV and the association, obviously, of the BSS component, coupling concretely changes for us as a developer, and the opportunities is opening to us very important challenges regard the way we are addressing that African market and the partnership with the utilities. Firstly, I would like to just emphasize the role of developer. Firstly, renewable energy projects are long cycles. We are taking 2 to 4 years of development, and then up to 2 years of constructions, and before we operating that infrastructure for 20 to 25 years. So it's a very long-term commitment with risk concentrated mainly on the middle phase of those, I would say, steps of developments and exploitation. We go through six key stage. Firstly, it's the project screening, checking for institutional feasibility, land availability with the partnering with the off-takers. And then we go for feasibility studies, more detailed one, covering technical, financial, environmental, and legal aspects, also regulatory frameworks analysis. Then what we call the risky stage. We go out looking for financing, negotiating also permits and license, draft PPA and concessional agreements with the different state and regulatory stakeholders we are pleased to involve into those developments. The most resource intensive phase with the least certainty after comes structuring, financial close, and the financial investment decision. Then construction, when we must stick to schedule, quality, and budget while reporting the lenders, obviously the partnering off-takers. And finally, we go for the operation where we need to deliver our technical commitments, performance, QHSE performances for at least 2 decades. The challenge we're facing, we can summarize those challenges into 4 main, I won't say concerns, but more I would say matters we have to address along the development and the modelization phase of the project. Firstly, is we face the challenge. We face the time challenge with 2 to 4 years of development. It's a long time on our business. Time works against us. Raw materials prices fluctuate. We can look about the lithium and copper curves here over the past year. We can see that there is an important volatility and unpredictable prices chosen as references by mainly the EPCs and the OEMs for the pricing of their equipments. When you lock in a price at feasibility stage, regarding the kilowatt per hour or any BSS services, it's really challenging to keep the to keep the economical efficiency on the project. The second challenge is about the transport and tax. We can see that importing BSS equipment in Africa means navigating between custom duties, shifting tax regimes, and complex logistics from the factory gate to the project site. The third point is technological evolution. As we are on long-term discussion with the partnering with the utilities, the market is moving very fast when we do consider the industrialization and the technologies into the BSS domain. Do we oversize today to secure the known lifespan of the BSS solution, or do we plan to repower it after 10, 12, or 15 years? What will be the impact of the sodium ion technology, for example? Will it disrupt our financial models? The fourth issue we have to address is the PPA duration, which is usually not synchronized with that, I would say, technology handling. It's 20 to 25 years, where I would say the OEM suppliers of battery technologies can grant the performance, the material and electrical performance for about 18 to 20 years. And finally, one of the last and the most important and unpredictable concerns we can address is about political, geopolitical also, and regulatory risk and stability we need throughout those, I would say, development period. About the services, so there is two, sorry, maybe I've been too far. About the services, so we address different type of services. We can deliver ancillary services, direct grid support for voltage regulation and frequency regulation. There are services that grid operators value greatly, especially in country where grid stability is fragile, we can say. We can also provide production services like PV smoothing, load shifting, moving energy across the time, and the potential for energy trading that makes the BSS truly flexible, and that can be developed into two way of commercialization, monetization. It can be also connected to the grid, but also standalone if we do consider hybridization or existing. Yeah.
Can I encourage you to start wrapping up?
Okay.
Thank you.
Okay, so at the end of this presentation, so I hope you will have a good, clear picture about what are the challenge that face developers into handling the I would say BSS development project in the continent, and the opportunity that the BSS can create through the different production and ancillary services it might give to as supporting, I would say, the network growth of the utilities. Thank you very much.
Thank you so much, Laurent. And it's an invaluable perspective to have, that of the people who are doing the project. So thank you very much for sharing that. Now, it is not too late. Can I ask all of the rest of the panelists to turn on their cameras and their microphones so that we can start the panel discussion part of this session. And I'd like to start. There's a few questions actually from the audience. So the first question is to you, Clever, from Idem Waniki. And the question is, the current ministerial guidelines on minimum standards for solar home systems signed on the 2nd of May 2025, there is a restriction on the wattage of solar panels. Panels must supply 20 watt peak or above, which limits what private sector players can import into Rwanda. My understanding is that smaller solar home systems that are affordable cannot be sold to the Rwandan people, hence limiting their access to lights. Please, can you advise if there is a plan to reduce this limit in the future?
Sure. Thank you very much. That's a very good question. And actually, I somehow provided a bit of clarity in my other presentation. Now the market is open. What is required is only to, at a certain capacity, which I think is 250 kilowatt hour, you have to register. You basically require a license from the regulator, but they opened up a bit, and there's no longer limitation on the capacity. It used to be anything below 50, you do not require to go to the regulator, but now that has slightly been improved. So I would say that that is addressed under the new energy policy, maybe being short and precise. Thank you.
Thank you very much, Clever. And next, I have a question from the audience as well, from Dio, for Faisal. So for Zesco, do you have any BESS operational currently, and what is your experience with this?
I'm not sure I got you correctly. Just say that, ask the question again.
Sure. So for Zesco, do you have some BESS operational now? And how has the experience been so far with it?
Okay. No, for ASCO, we don't have any base that is on the range of a megawatt that is installed at the moment. So we have no experience at the moment with base.
Okay. No, thanks very much, and I hope that that responded to the two questions from the Q&A section. I want to bring in a speaker who didn't do a presentation this time round, but from the OEM side, so Titus from Jinko ESS. For you, kind of many African grid codes are still catching up with the technical requirements of inverter-based resources. And BESS specific provisions, as we've seen, are either absent or in draft or have just been done. For you, what are the most technically consequential gaps you encounter in practice, particularly around inverter frequency response, islanding detection, and fault ride-through? And how do you work with grid operators to agree a connection standard that is both technically appropriate and commercially viable?
Thank you, Benjamin, and good morning and also good afternoon, everyone, from everywhere you're tuning in from today. And I think it's quite a very long question. I think there's so many responses, but because time will not allow, I'll try to summarize. And I'll say that, you see, look, most of the African grid codes that we have currently, we actually developed based on, synchronous generation. And what we've seen is that most of them are actually being stressed because of the rapid growth of IBRs, that is the inverter-based resources, likes of solar, BESS, wind, etc. And I think from my own perspective is that the challenge is not simply because of the absence of BESS specific classes, but more of lack of clearly defined dynamic performance requirements. And these requirements mainly requirements for maybe PCS to be grid forming or also grid following as well. And from an OEM perspective, we also seeing gaps in, let me say 3 different parameters. There is one on, the PCS frequency response requirements, which is usually not clearly stated. We still find that most of the grid codes are still specifying conventional governor response characteristics that was mainly intended for rotating machines, without clearly defining on the requirements for fast frequency response, also looking into no clear drop response parameters, no clear parameters on SOC management as well, that is during the frequency support. So you see all this, dynamics actually causing some bit of, uncertainty in the plan design. And sometimes as OEMs, we could interpret this as, we could have different interpretations of frequency supports. And you see, sometimes that you'll find that the utility, let's say Zesco, could be referring to maybe they could be expecting, let's say, simple PF drop response, while you see other utilities could be expecting maybe virtual inertia on grid forming operations. So you see that, keeping in mind, it has to be a trade. It's actually a challenge, of course, that has to be addressed. The good thing is that currently the number of simulation softwares, advanced, grid modeling simulation softwares as well, like PSCAD, BSS as well, which could, assist in early grid studies before, the commencement of the projects. And the other gap that we're also seeing is that, lack of clarity when it comes to grid forming standards as well. We find that most of the grid networks that we have in the region, there is no clear requirements for grid forming, and in the sense that they've not clearly defined, parameters of, let's say, the voltage source behavior. There is no clear parameters for ACR as well, clear parameters for, let's say, synchronous machine requirements as well, or even sometimes also on the stability matrix that is not clearly defined. So you see, without these definitions, we might find that some utilities may over request, some may also under request as well. And in some instances, the OEM may over design or also may or under design as well. So I think this could have some commercial and also technical implications. Lastly, is that on this topic is that to also mention the other parameter on the FRTs. I think someone mentioned during their presentation is actually one of the parameters that is highly inconsistent in most of the utilities, where there is no clear definition of VT or rather voltage time, right through graphs. There's also no clear definition of fault. Faults that is for asymmetrical or maybe symmetrical faults, depends, and also on the conditions for ACR as well, that is not clearly defined. And if there is no clear definition for this, it could actually be problematic to most of the power conversion systems as well, which is, we find that they're basically technically capable to handle this FRT behavior, but sometimes too much aggressiveness could actually be leading to some conflict also with the protection system that is already in place. So, but you see, being a challenge, it could also be addressed by, rigorous modeling, that is EMT modeling as well. And the good thing is that as OEMs, we also provide an avenue for factory acceptance testing and also site acceptance testing as well, to basically to validate the designs and also the actual operating environments. So I think just to save on time, I would just want to highlight the three different points that we're looking into from an OEM point of view.
So thanks for that, Titus, and that was very, very comprehensive. But yeah, it sort of seems to kind of sum it up. It's BESS is neither a silver bullet nor is it a kind of primitive form of technology, and it's worth kind of distinguishing between those two in order to get your design right. No, that's thank you for that. And next, I want to turn to Hlobisile, because it sort of ties into what Titus was talking about. So obviously, as Eswatini moves from a heavy import dependency from SAP towards more domestically connected solar, which constraint does your planning team expect to encounter first? Is it the rate of change of frequency following a loss of a large import block? Is it voltage instability at the point of connection for new solar plants, or thermal limits on your internal transmission network? And how do you currently see storage factoring into your planning response to each of those things? Hlobisile, if you're still with us.
Oh, thank you so much. Thank you so much. For us as Eswatini, I'll just pick the points. You remind me if I didn't catch it correctly. But for the frequency response, we are highly dependent. As I've said, we've got a strong inertia because we've got an interconnector from South Africa to Mozambique. It's not a priority for us to incorporate BESS, for us to assist on grid stability, because our inertia is very, very strong. That one, for a grid forming inverter for us, for Eswatini, it cannot be a priority now. Although, because we don't have even for our grid code does not define properly these technologies, but it's still going to be amended because the energy landscape is changing. But for that, to support the frequency response for us, it cannot be a priority since we've got a strong inertia via our interconnection. So For the weakest, for the voltage instability, when you integrate our embedded generation or our small scale generation plant, we do experience at POC the voltage instabilities. But then now BESS is going to assist us further so that maybe we can mitigate that to regulate the voltage to be within the technical limits that are required, since we're governed by the Eswatini grid code, the connection code for Eswatini. I don't know whether I've sufficiently.
I think that does, and I think that, yeah, I don't know. I think there's a clear thing. There's a clear element for where storage can play a role in all of that, and I think that, yeah, kind of building on Titus's point, and what you were saying as well. Yes, it's about working it in the most sensible way, possible. So thank you for that response. So, Laurent, I want to come back to you and just hear a little bit from your side as a person who's doing projects on the ground. So across the markets that AFSIA operates in, which part of the technical connection process actually creates the most delay for you? Is it load flow and fault level study methodology, protection coordination, so on and so forth? And what has AFSIA actually standardized internally to reduce the amount of back and forth that you have with utility technical teams?
Thank you. I think that the most important activity we have to conduct, partnering with the utilities, has been resumed perfectly by Titus. We have a real challenge on the grid injection studies, whatever we're discussing about static, but mostly contingencies and dynamic studies, where we have to deal with the level of certainty for the updated model. Grid model available at the national level with partnering with the utilities. We have also to coordinate, to take some risk, some assumptions about what are the schedules assumed regarding new power plant, whatever discussing about high inertia, I would say hydropower or thermal plants, but also the concurrent renewable plants that we have to clearly identify, and we have to assume regarding the time they will be connected to the network. And so we have to adapt constantly almost our design to comply with that, I would say, technical frameworks, but also with the regulatory frameworks and the grid code. And associating in the same times the suppliers, the OEMs, in order to be sure that the solution will deal on a long-term perspective the requirements of the network. The internal organization of AFSIA Energy, we associate two different paths working. The first is we have to develop our internal expertise. It's mandatory for engineering and project development teams, both I would say from the back office to the front office discussions with the utilities, the F-taker, and at the same time we're developing our partnership with the several international engineering firms which are already advising the utilities in order to go straight to the difficulties, to the technical adaptations to the requirements. Thank you.
No, thanks so much for that, Laurent. It's interesting to hear from the other side how this is tackled, because we've heard from EEC, EUCL, and ZESCO that it's not particularly easy from their side either. So I'm glad that we've covered that. So there's a lot more questions that I could ask, and certainly have loads on my mind. But what I want to kind of zoom out a little bit and kind of have some kind of high level thoughts from all of you here. So we've covered kind of a little bit of grid codes, frequency response, connection processes. We haven't really got onto contract structures, but we can. that's also something we could have covered. But stepping back from all that technical detail, beyond the engineering challenges we've discussed today, what is the single most important enabling condition that still needs to be in place for grid scale storage to move from kind of pilot and early stage projects to routine procurement across your various different markets? And how confident are you that it will be in place within the next 3 to 5 years? I'll start with Clave, if you go first.
Yeah, thank you very much. I really appreciate. I'll kind of confess that we don't have base for the moment, but we intend to have one, and that was actually is intended to address the very specific issue that my colleague from Eswatini was saying that being interconnected, in a sense, you obtain inertia by the virtue of the fact that you lean to a bigger system. But our situation has been slightly different because we are part of the East African Power Pool, and fortunately or unfortunately, we tend to interface with the EAPP via a single link. And if there's a disturbance that affects that link, automatically we are somehow affected. And we believe that the best that we intend to onboard is basically meant to specifically address that. And how we intend to stagger or distribute is being assessed to make sure that we position it very strategically in a sense that we no longer face a risk of a single point of failure. However much we're opening up to interconnect with other countries, but also trying to address that specifically. But also, I think what we're doing actually is, I mean, BESS is real. It provides solutions that we don't have at the moment, and you can invest in hydro, in gas, and all sorts of technology. But in terms of response, I think it is a bit very flexible compared to other solutions. And what we're basically trying to increase, which has been more of a gap, is to increase the knowledge and understanding of what is happening, and also to properly structure the right deals. And given that knowledge gap, how do you make sure that the risk is well distributed? There's a bit of risk sharing so that you don't buy and operate as a utility because you don't have quite significant knowledge. But also you have adequate knowledge that if at all you provide that to the independent power producer or a third party, you also don't lose in the process because you've transferred all the risks to the service provider. Thank you.
Thanks so much, Clara. And yes, so avoiding that single point of failure that you have with the East African Power Pool, and also developing in-house knowledge and better risk allocation for best projects. So thank you for those insights. So Hlopsile, your thoughts on that single most important enabling condition that needs to be in place for grid scale storage to move from pilot and early stage projects into routine procurement in Eswatini?
Okay, I think we need also to amend our grid code and even our policies to incorporate the different dynamic model controls that our storage can support. Yes, our grid code do incorporate power pack modules, of which the BESS is part of that. But now the dynamics models that the BESS can support and the policing that comes with it, we need maybe to amend that so that maybe it can give us a way forward how we can now integrate them with the different support. Because as we have said, sometimes it cannot be a peak shaving, like it can give you the megawatts, but it can support the voltage onto the grid. So we need also to maybe amend those policies for that, even Eswatini as well, so that it can support the grid forming and the grid following in the same context, and also for developers flexibility and the ancillary services as well, so that maybe it can also have the flexibility. As much as Eswatini has got energy storage, system guidelines, but now we need to dive deeper and also maybe incorporate those policing and also those grid codes requirements within those structures. Thank you.
Thanks. And I think that's, I mean, that's an excellent place to lead on to maybe Titus, your thoughts on the single most enabling condition. Titus.
Yeah, you see, the thing is that Africa. Yeah, can you hear me?
Yeah. Go ahead.
Yeah, I can say that Africa, as a continent, is basically moving beyond the proof of concept for, for grid scale battery storage. And you can say that the investment is now real. We've seen some, procurement happening or other tenders happening in South Africa, Morocco, Egypt, and some other countries as well. And you see, the thing is that we need to just move away from the biggest misconception that the falling battery prices, globally will automatically lead or rather translate to rapid deployment of battery storage. So I don't think this does, because there's still bottlenecks that needs to be addressed, including, having bankable revenue models for battery energy storage, also having clarity on what Wakili pays for flexibility, and also reinforcement of the transmission infrastructure as well. And it also comes into the bankability of the off-taker by having, utility that is basically credit worthy. And of course, looking at also the aspect of the operational capability of the off-taker as well. So those are some of the elements or other bottlenecks that I think that needs to be addressed. And from an OEM point of view, we feel that the technologies are already available. It's actually mature. It's already been tested, so we don't need to reinvent the wheel because it's already tested in mature battery market as well. And I want to be more of optimistic, but cautiously optimistic in this particular case, that within the next 5 years, battery storage in Africa is expected to transition from isolated pilot projects in different countries into having battery storage as a mainstream energy infrastructure in the region.
Thanks so much, Titus. Yeah, I agree. Battery storage does, the price cost does somewhat open the door, but you still have to walk through it. And then, so to talk to Mfaisa, your single most important enabling condition, please.
Okay, so for me, it's basically the issues around cost, although you're saying they don't affect much of the deployment. For majority of African countries, is creating a business case for BESS and seeing how quickly it can be deployed. So if we have a bankable solution around BESS, they'll be quickly deployed if people can find financing. So now, usually in terms of our rates for Zambia, they are usually flat. We don't have peak rates and off-peak rates. So for us, we have a system that has a flat rate. So in terms of installing battery and looking at its profitability, I'm at really at the moment that will not support it, because in most cases we're selling power at a flat rate. So for Zambia, unless people with these PV plants, they charge with a battery and charge with contracts with other off-takers. But as a utility, us at the moment, it'll be difficult for us to agree and say we are trying to explore those ones that are utility based, that are going to be used for areas where we have a weak network. We want ancillary services also provided by the BESS, so that the network is stabilized as you deploy the BESS. So those are some of the key things that in cases where people have been required to bring in the BESS, That's the forecast that we've taken. Thank you.
So that's particularly interesting. So leaning much more on the kind of ancillary and grid level services that BESS can provide, and that Laurent went into a little bit as well. I think it's but thank you for that. And last but by no means least, Laurent, your single most important enabling condition.
From my point of view, we have a fantastic technology, the BSS. It's an opportunity for supporting energy transition, energy access, and energy availability. And that technology is very flexible to address a wide panel of needs for the networks and the utilities. And what is very important, worth mentioning, is that technology is cost driven by the electrical vehicles mass market. So we'll continue to have an optimization of the cost. We'll continue to have new opportunities. And so what I think the most important need we have identified from our side, if we can consider as a developer, it's to have regulatory frameworks and adaptations of the domestic and the regional grid codes, supporting the way to go forward with the utilities and any off-takers. So I think we have a quite promising future-proof, I would say, business and solutions development and utilization developments with the BSS in the coming decade. Thank you.
Thank you so much. And with that, we come to the end of our third day of the AFSIA e-conference on storage. I would like to place on record a huge thank you to all of our panelists today in both sessions, but in the second session, in particular, Mvaizafiri, Clava Gakwavu, Klopsile Clofe, Titus Koek, and Laurent Roineau. Thank you very much, all of you, and thank you very much to everyone who's joined and stayed for the entire day. It's much, much, much appreciated. And don't go anywhere tomorrow between 10 and 12, because as you can see, we have some excellent sessions coming up, focused on market intelligence for storage across Africa, taking in examples from Zambia, South Africa, and from around the world. And then we will have a deep dive on the regulation and policy landscape with luminaries such as the African School of Regulation, IRENA, Energy Regulation Board of Zambia, and EPRA from Kenya. So thank you very much today. Thank you to all the speakers. Thank you to all our partners. And thank you to all of the people who have participated today, whether on Zoom, LinkedIn, or YouTube. Thank you very much, and see you all tomorrow. Goodbye.
Thank you. Goodbye.
Bye.
Thank you.
Bye.